Hello everyone, welcome back to my YouTube channel. So today we are solving the Leetcode challenge, remove elements. We are given an array, an integer array norms and an integer value. So we want to remove all occurrences of value in norms in place. So for instance, if we are given an integer value of 3, something like this, and so this is our norms and our value is 3. So essentially what we want to do is remove all occurrences of 3 from this norms array in place. And if you hear this in place, we've kind of dealt with it before. We've solved a similar problem to this. I'll link it somewhere in the cards. And we're also told that the order of elements may not be should not be changed. So essentially we have 2, 3, 2, 3, and we are getting rid of 3. So what should be returned should be 2, 2. So the order should basically remain the same, but without the elements that we are to remove essentially. All right, now let's get right into the code. I said let's get right into the code, whereas we also want to get right into the algorithms of how this work initially. So first we are given, let's assume we're given this array and the value that we want to remove is 3. So what we want to do, since we are told to do this in place, we'll just go right ahead and use our two pointers. Two pointers is the best technique to solve an array problem that we are to solve in place without changing the order of things, without using an extra space essentially. So how two pointers work in this case is we initialize two pointers, a left and a right pointer, and we do this slow air, fast air, where one pointer moves faster than the other. And in this case, I've chosen my right pointer to be the fighter that moves faster than my left pointer. So what do we want to do in this case? So first we want to check if we encounter the value that we are to remove. If we encounter the value that we are to remove, we don't want to do anything. And that's intuitive, because don't we want to remove it? Yes, we do want to remove it, but since we are not given an extra space, we are not allowed to use an extra space. Essentially, we cannot just remove it anywhere else. So we are instead going to replace the value. So we identify, first we are going to check if we see this value. What do we do? Actually, we do nothing because we do want to replace you. So we do nothing. But then we move our right pointer. Move our right pointer to the next value. So our right pointer moves from where it is to the next one. Remember, it is the pointer that moves faster than the previous one. Now we encounter a value that we do want to keep. It is not equal to the value we are asked to remove. So we need this value. So what do we do now? What we do now is we replace our left pointer, we replace that value with our right pointer. Now, how do we know that our left pointer does not contain a value that we do not want to lose? That is where we started from. So if we ever encounter a value that we want to keep, for instance, we want to keep 2 because 2 is not the value to be disposed of, it is 3. So if we want to keep 2, we are going to move our left pointer. So we're only moving our left pointer when we encounter a unique value. By unique, I mean value that we're not removing, a unique value in our array. But whenever we do not encounter such a number, our left pointer just stays put. Kind of like is the one keeping track of, oh, there is the betrayal here that we want to get rid of. So whenever our left pointer is, we identify that we are to get rid of that guy. Is our store guy watching for who we want to get rid of? Meanwhile, our right pointer is the one on the lookout looking for whom to destroy. But our left pointer stays put with whichever culprits to be removed that we already found. I hope that is clear somehow. Now our right pointer finds a guy that we want to keep, and we know that our left pointer is on a guy that we do not want to keep. So what do? We do a swap. We swap what we have in right with what we have in left because we do not need left. We are asked to get rid of left. So we move right over to left. We put our value here too, and after doing this swap, we move our left finally away from that guy because it is no longer the value we want to remove. We've already kicked that guy out. We have nothing to do with him anymore. Is gone essentially. So we move him from where he was. And of course, our right is always on the move, and we move our right back to this value. Now that we've moved our left and right pointers, we get in a bit of an interesting situation where we see that our left pointer is holding down a value that seem like the value we want to keep, but our right pointer is also on a value that we want to keep. So what do we do in this instance? Recall what we are doing is whenever we encounter any value that we want to keep, we move that over to our left, because the point is that wherever our left is, we probably do not have a value that is to be kept there. And that is exactly what we're going to do. So we found a value in our right pointer. What we are going to do now is move this value from our right pointer to our left pointer. Now I know what you're thinking. You're like, oh, but essentially we do want to keep 2, right? 2 is part of the numbers we are to keep, and why are we replacing it? So what essentially is going on here is 2 technically doesn't live at this address anymore. 2 is now empty. Recall we moved 2 over to the criminal's house, aka 3. Actually, not a criminal, but you get the point. So we moved 2 over to 3. So technically, this space is up for grabs. It technically is freed up because we have moved the value back to 2, back to where index 0, where 3 probably was. So now that 2 lives there. So now that we've done that move, recall the next step is we move left and we also move right. So whenever there is a change of house, we move left and then we also move right. So whenever right is on a value that we do not want to keep, we do not do anything. Why we do not do anything is because we don't want to store a value that we do not need. We are asked to eliminate 3. So essentially, when we get to a value that we do not need, we essentially do not store it. And this is the end of our array. Our code terminates, and we return left, because left, the number of times left move is basically the number of times that we encountered a value that is not 3. Recall we only moved left when we did a house shift, and the house shift occurred for values that are not 3. And if you count the number of times that we moved once here, we moved second time here, and that is 2. So essentially, the number of unique numbers, or numbers that are not 3 rather, in our array is 2, which corresponds with the original array. We have 3, 2, 2, 3, and only 2 twos are not 3, hence our answer. Now let's jump right into the code. So what we want to do here is we want to define our pointers. I'm going to define the left pointer and set it to 0. That's the first index. Define our right pointer, which is initially going to be 0. And while that is less than the number of items in our array, we are going to keep on executing this code. So what we want to do here, we want to check that our norms at right is not equal to the value. So if it's not equal to the value, then we want to shift it. If it's equal to the value that we are asked to remove, we're just going to ignore it because it's going to be moved over anyways. So our norms left, recall our left pointer, now takes the value that we have at our right hand side, and we also want to go ahead and increment our left pointer, so that also moves. And at the end of our code, we want to return left, essentially, because that should return the number of non-value that we are given in the problem. So first we want to run this. We see that test case is accepted. Let's go back and run a submit on that. And while this is running, we can just discuss complexities. For time complexity, we're only running our array for we're running our code for as long as is the length of the array. So that is an O of n. We are asked to do this in place, so we cannot technically use extra space, which by default makes this a constant space O of 1. I hope this video was helpful to you in some way. Please leave some feedback and like if it was. See you in the next video. Bye.